Whether we're looking at a physical change or a chemical change, for all changes, the total mass before the change has to equal the total mass after the change. This is called the law of conservation of mass. And we can see, let's say we burn natural gas. Natural gas is an example of a chemical called a hydrocarbon. Hydrocarbon means it's made up of hydrogen and carbon. Whenever you burn something that has carbons and hydrogens in it, you always make the same two products, which are carbon dioxide and water. So if we took some natural gas, which is mostly the chemical methane, and we react that with oxygen gas, and oxygen gas is called a diatomic molecule. It's made up of two atoms of oxygen together. There are some common elements that exist as diatomics like this, and you should remember those. It's easy to remember if you remember the word Hunkelbrief. So that made-up word Hunkelbrief means hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. These are found most stably as two atoms of that element chemically connected together. Now, it is possible to talk about oxygen and refer to a single oxygen atom. It's also possible to talk about ozone, which is O3. However, in a problem talking about reaction with oxygen, that implies we're talking about the most stable form, and the most stable form of these elements happens to be diatomic. So if we took natural gas, react that with oxygen in the air, we're going to make carbon dioxide, which is one carbon, two oxygens. You're going to learn about naming these later on. And water, which is H2O. Conservation of mass says, let's say we start with a certain amount, 800 grams of natural gas, and we react that with 3,200 grams of oxygen. And we know, we measure the carbon dioxide and we get 2,200 grams of carbon dioxide. And the question is, how many grams of water would we make? The law of conservation of mass says the total mass of everything we started with, 800 plus 3,200, so that's 4,000 grams where we started. Has to equal the total mass of everything we ended up with. So if we know the total has to be 4,000 grams, 2,200 plus 1,800 grams of oxygen, or 1,800 grams of water must have been produced, according to the law of conservation of mass. Now, these numbers are made up right now, but later on, what you're going to see is a topic called stoichiometry, which lets you relate these masses together.